Okay, so this is the table that I gave you, the table that is the values of x, L1 and L2 and of E2 over E1. So the question D1 says plot a graph of E2 over E1 on the y-axis against x on the x-axis. So what do we do next? What we do next is we go forward and we have to label our axis, because E2 has to be on the y-axis, E2 over E1, according to the graph that we must draw. So first things first, label the axis, the y-axis, E2 over E1, then the x-axis, we put x. Then the next thing is to try to find scale. And when we are looking for a scale, we have to consider the minimum and maximum values of E2 over E1 and the minimum and maximum value of x. So to look for the scale, we have to consider that the minimum value of E2 over E1 is 0.79. The maximum value is 11. We need a good scale that can fit into the space provided. So that's what we have to work towards, to finding a good scale. So we'll use this space used to determine gradient and y-intercept. We'll use a pencil, of course, in the exam to calculate this. So remember, for E2 over E1, the minimum value is 0.79. That's what is supposed to be on the y-axis, and the maximum value is 11. So we come here to this space, and personally I use this formula. I use the formula scale is equals to the 11, the maximum value, minus the minimum value 0.79 divided by 10, which gives me, let me punch it in the calculator. Okay, sorry for the delay, but this gives me, I think, 1.057. So wait for it. Okay, 1.021, sorry, 1.021. So now I want to find a proper scale. And a proper scale, what we mean is that we want to see how to separate values on the y-axis, how to separate what we label on the y-axis in a manner that is viable. So the proper scales are 1, 2, 2.5, 5, and 10. These are the scales that are not awkward. And when we are talking about these scales, we have to fully understand what we mean. For example, 1 there, we are talking about all the multiples of 1. That can be 10, 100, 1000, going forward like that, or 0.1, 0.01, 0.001, or we can go for 2, which is 2, 20, 200, 2000, like that, or 0.2, 0.02, 0.002. So that's what we mean when we talk about scale. But if you consider that for the what we got there for scale, the value is 1. So it means where is 1? 1 is between 1 and 2. And the truth is that it is nearer to 1 than it is nearer to 2. So we choose our scale on the y-axis as 1. So our scale on the y-axis, you might think that it was an open and shut case, but it's never an open and shut case. It just so happened that for this practical it has open and shut case. So now let's look for the scale for the x-axis. And as you saw, the minimum value on the x-axis is 54, and the maximum value on the y-axis is 98. So on the x-axis, I say 98 minus 54 divided by 6. And then we use our calculator to punch so that we can see what we'll get. So we will get 7.33. That's it from the calculator. I think this is correct. We get 7.33 if you divide what we get here. Okay, so then we go to the scale. 7.33 is between 5 and 10. That's 7 is between 5 and 10. So as it is between 5 and 10, our goal is to compare where is it near. Is it near 5 or is it near 10? In which case it is near 5. So we'll choose 5 as our scale, as a preliminary scale. But sometimes 5 might not work, so in which case we'd have to use 10. So we choose 5 as our scale for the x-axis. But if it doesn't work, which happens sometimes, we'll use 10 as our scale. So for now, 5 is our scale on the x-axis. So we erase this. We use pencil for that particular part. Even though the other, for like this table, we need to use a pen. In this case, we use pencil. But if you check on the values of the y values, they start from 0.79. So we don't have to start from 0.79. If you compare from 0.79 to 11, we can start from 0. And if we start from 0, labeling our y-axis, starting from 0, we found that the scale on the y-axis has to be 1. So we'll be labeling 0, 1, 2, like that. That's what we mean scale. What we mean scale is what we are adding each time. Each time to 2 we add 1, we get 3. To 3 we add 1, we get 4. To 4 we add 1 again, we get 5. Continuously like that until we reach the top part. This is a nice scale. We don't put readings. Students usually make the mistake of putting readings that are in the so here I'm just going to pause this one so that we can continue from here.